Welcome back, my friends. In this video we will do some practice on Cramer's rule for 3x3 systems of linear equation, because I've noticed that most of you are so much interested in practice question. So let's start with the first practice question. We have 3 linear equations and 3 variables. So 3x plus 4y plus z equals to 17. 2x plus 3y plus 2z equals to 15, x plus y equals to 4. As you can see, we have 3 linear equations, and each equation has got 3 different variables, x, y, z, x, y, z. Here we have x and y, that means the z is missing. Whenever a variable is missing, that means the coefficient is 0. So you can simply substitute it with 0. So here, once more, you have 3 linear equations instead of 3 different variables. And we want to solve and find the answer through Cramer's rule. So first thing first, you have to rearrange it and make sure all the variables are nicely aligned underneath one another. So what I mean is, if this one starts with x, then y, then z, it should be exactly the same thing for the rest of the equation. After that, we have to form the determinant. So in this method, for a 3x3 linear equation, systems of linear equation, you need to calculate 4 different determinants to find the value of x, y, and z. First thing, we will start with calculating the determinant for the coefficients of our variables. So the first determinant we form, that sometimes some textbook use triangle to form the determinant, is the coefficient. So in this 3x3 determinant, we just put the coefficients of x in the first column, y in the second column, and z in the third column. So I just put it for you to just remember. So 3, 2, 1 are the coefficients of x, 4, 3, 1 coefficient of y, 1, 2, and 0 are the coefficients of z. Then in the next step, we have to find the value of this 3x3 determinant. Remember, if you want to know how to calculate a 3x3 determinant, you can always refer to my previous video. So here we start with the first main number. When we start with this main number, this row and this column will be eliminated. And what is left is a 2x2 matrix, which is 3, 2, 1, 0. Okay, so here 3 times a 2x2 matrix. Then the second main element, which comes with a negative sign, would be, so we are eliminating this one, and also we are eliminating this one. So what is left? 2, 2, 1, 0. Okay, so negative 4 times a 2x2 matrix. And then the third element is 1. And if we consider the third element, then we are left with 2, 3, 1, 1. Okay? So here we broke the 3x3 determinants to 3 2x2 determinants. Now let's calculate each 2x2 determinant. Here the answer would be 3 times. If you want to calculate a 2x2 determinant, this is how we calculate 3 times 0 minus 2 times 1. So that would be 0 minus 2. Then for this one, negative 4, then 2 times 0, which is 0, minus 2 times 1. Okay, 2. And then for the last one, it would be 2 times 1 minus 1 times 3. And then you simplify and get the final answer as 1. After that, we have to find another 3 determinants. After that, we have to calculate the determinant of x, in this determinant, because we are trying to form the determinant of x, and x is the first variable, so the first column will be replaced by the constant, which is 17, 15, and 4. And the second and third column, which is related to y and z, would not change, would stay the same. Okay, so again, let's see how we can calculate this one. So the first element is 17. Okay, 17 times, we will have to eliminate the other two. So we are left with 3210. Okay, the second column is 4. It comes out with a negative sign, so it's negative 4. And let's see, if I eliminate the first row and second column, so I would be left with 15240. Okay, and this is exactly what I have here. Okay, and then the third main element, it's 1. So let's see, if I eliminate the first row and third column, I would be left with 15341. Okay, so once more, a 3 by 3 determinant is broken down to 3 2 by 2 determinant, and then we have to find each 2 by 2 determinant value separately, and then do the calculation, simplify, and find the answer. So here again, the first one would be 17 times. Okay, so the first 2 by 2 determinant would be 3 times 0 minus 2 times 1. Okay, the second one would be negative 4, and it would be 15 times 0 minus 4 times 8. And the third one would be 15 times 1 minus 4 times 3. And if I simplify, the final answer would be 1. The next determinant which I have to form is the dy, and y is the second variable. So x column wouldn't change, the z column wouldn't change, but the y column would be replaced by the coefficients, constant, sorry. So 17, 15, and 4. Again, once more, when I want to calculate this 3 by 3 determinant, so the first main element is 3. So I just put down the 3, but then the first column and the first row would be eliminated. So I would be left with, let's see, 15240. 15240. Perfect. Now the second main element would be 17, which always come with a negative sign, so it's negative 17. So again, the second column and the first row would be eliminated, so I'm left with 2210. And then for the third main element, which is 1, this column and this row would be eliminated, so I'm left with 21514. The next step would be once more calculating 3 2 by 2 determinants. So the answer would be 3 times 15 times 0, it's 0 minus 4 times 2, 8. Okay, negative 17, 2 times 0, it's 0, 1 minus 2, it's negative 2, 2 times 4, it's 8, minus 15. And the final answer is 3. The third determinant which I have to calculate, it's the determinant of z, and z is the third variable. So the first column and the second column, which refer to x and y coefficient, are not changed, but the third column is replaced with the constant. So here again, the first main element would be 3. If I want to if I want to eliminate the first column and the first row, then I'm left with 3, 15, 1, 4. Okay. Now the second main element, it's 4, which always come with a negative sign. So again, these two will be eliminated, and I'm left with 2, 15, 1, 4. Okay. And now the third main element is 17. So when I eliminate that, I'm left with a 2 by 2 determinant of 2, 3, 1, 1. And after that, I have to calculate the 3 2 by 2 determinant. So it would be 3 times 12 minus 15, okay? Negative 4 times 2 times 4 is 8, negative 15 plus 17 times 2 times 1 minus 3. And after simplification, the answer is 2. Okay, the next and the last step would be to calculate the value of x. The x value would be determinant of x over the d, which is the determinant of coefficients. So the dx is 1, the d is 1. So x would be 1 over 1, which is equal to 1. Y would be dy over determinant d, which is 3 over 1. And the final answer is 3. The z is determinant of z over d, and the final answer would be 2 over 1, which is equal to 2. So here we could say that therefore our solution is x, y, z, which is equal to 1, 3, 2. So the x is 1, the y is 3, the z is 2. Okay, this is the end of the first example. I hope you enjoyed it. So just to sum it up, when you have a system of linear equation, which is 3 by 3, first of all, you have to do simplification, then rearrange it and make sure all the variables are nicely aligned. Then you have to form 4 different determinants. You start with the coefficient determinant, then you form the dx, dy, and dz, and get the answer. Calculate each determinant and get the answer. Let's do another example. This is example 2. Here again I have 3 linear equations which I simplified, and this is nicely aligned. So x, y, z, x, y, z. Here the x is missing, so the coefficient of x would be 0, and then the constants are 6, negative 3, and 0. So here, first thing I have to do is to form the d, or the coefficient determinant, okay? So here, instead of using the triangle symbol, I'm using the d. It's the same thing, it doesn't matter. So the first column would be x coefficient, then the second column would be the y coefficient, and the third column would be the z coefficient. So we start with x, so that would be 1, 2, 0, right? For the y, that would be 1, negative 1, and 3. For the z, that would be 1, negative 1, and negative 2. So I form the d, which is the coefficient matrix. Then I have to find the value. In order to find the value again, so it's always helpful to use 2 pens when you're trying to find the value of a 3 by 3 matrix. It's really helpful. So again, the first main element, it's 1. The first row and this first column would be covered. And then what I'm left with is negative 1, negative 1, 3, 2. Okay? And that is here. So the second main element is 1. So it always comes with a negative sign. So the first row and the second column would be eliminated. What I'm left with is 2, negative 1, 0, and negative 2. And then for the third one, it's z. First row, third column, 2, negative 1, 0, 3. And then the next step would be calculating the value. So the first one, the first 2 by 2 determinant, it's 1. Negative 1 times negative 2 is 2. Negative 3, which turns out to positive 3. The next one is negative 1. So here, negative 1, then I have a negative from the formula. It turns into positive 1. 2 times negative 2 is negative 4. Negative subtracted from 0. The third one would be plus 1. 2 times 3 is 6. Subtracted from 0. Then if we calculate the final answer, it would be equal to 15. Next step would be calculating the dx. This is one of the determinants that we have to use with the sub-index of a variable. So here we have the D, which is the coefficient matrix, and then we have three other determinants which each have got a sub-index of one of the variables, dx, dy, and dz. So here, because we are calculating the x, we are talking about the dx, and x is the first variable. So the first column would be substituted by the constant, which are 6, -3, and 0. But the second and third column would not change, so they stay the same. So here I would have a 3 by 3 determinant. Now let's calculate. So the first main element is 6. So it would be -1, -1, 3, -2. The second one would be 1. It comes with a negative sign. So it would be -3, -1, 0, -2. And then the third one would be +1. Let's see, -3, -1, 0, and 3. So here, after this step, you have to once more calculate the values. And then if you do all the calculations, you will find out that the dx would be equal to 15. And I really advise you to just do a few of these 3 by 3 determinants by yourself. It sounds easy before, but it's very important that you start solving them from A to Z. So you make sure you get the right answer, because there is so much calculation involved. And then if you miss, if you make a tiny mistake, the whole thing would be messed up. And that's why it's very important for you guys to do a couple of these before your exam. Next step would be calculating the determinant of y. Y is the second variable. So the first variable x and the third one, which are the z, wouldn't change, but the second column would be replaced with the constant. So here 1, and then the first row, the first column, -3, -1, 0, 2. The second main element, it's 6, comes with a negative sign. So what I'm left with, 2, -1, 0, -2. And then again, the third main element, it's 1. Okay, so if we are talking about this one, the first row, and then this one, which is the third column, would be covered. And I'm left with 2, -3, 0, and 0. After that, I calculate all the 2 by 2 determinant, and I find out that dy is equal to 30. The next step, I have to calculate the dz, and dz again, as I just mentioned, z is the third variable, so the x and y would not change, but the z column would be replaced by the constants. And then I calculate this 3 by 3 matrix by breaking down into 3 2 by 2 matrices, and then I find do all the calculation, and I find the answer, which is 45. You can pause this video at this point, try to do all the calculation on your own, and check your answer and see if you can get 45. Next step would be calculating the x, y, and z. So the x would be dx over d, which is 15 over 15 equals to 1. Y would be dy over d, which is 30 over 15, and it's 2. And z is 3. So here, by this rule, which is the Cramer rule, you could calculate the x, y, and z. So what I suggest here, especially with a question which involves lots of calculation, after you're done, you can always go back and check your answer. So I have the values for x, y, and z. I pick up one of my equation and try to substitute the value, and want to make sure that it satisfies the equation. So one of the equations that I had was 3 times y minus 2z is 0. I will substitute the value for y and z and see if it's actually equal to 0 or not. If it's equal to 0, then that means that my answers are correct. So 3 times the y value is 2, negative 2 times the z value is 3. So 6 minus 6 is 0. Perfect. So that means the value of y and z are correct. So let's try on another equation with 3 variables, which it's better because, here we had 3 variables, and I want to make sure that all the variables are calculated correctly. So 2x minus y minus z, it's in one other equation, and after substituting the value for x and y and z, it should be equal to negative 3. And let's see if we do so, does it really equal to negative 3 or not? So 2 times x, and y is 2, and it comes with a negative sign. So z is 3, comes with a negative sign. So on this side we have 2 minus 2, which is 0, negative 3, and negative 3 is actually equal to negative 3. So that means the values of x, y, and z are correct. Let's move on to example question 3. Here we have another 3 equations which are simplified and arranged. They are nicely lined up. The variables are nicely lined up. So we start by forming the coefficient determinant, which I show with D. Some people prefer to use the triangle symbol. So the first column refers to the first variable, the second column refers to the second variable, and the third column refers to the third variable. So I just put the variables in the coefficient determinant: 1, 2, 1, 1, 1, negative 3, and 1, 3, plus 1. And the constant would be 2, 9, and 10. And I just put the constant in a matrix: 2, 9, 10, 2, 9, 10. The next step would be forming calculating the determinant, which it's a 3 by 3 determinant, which breaks into 3 2 by 2, and then calculating the values and finding the answer. So after calculating all these 2 by 2 matrices determinants, your final answer should be equal to 4. Then let's form the dx, determinant of x. X is the first variable, so y and z doesn't change, but the first column would be replaced by the constant. So 2, 9, 10, and then we break it into 3 2 by 2 determinants, find the answer, which happens to be 4. The next determinant we have to calculate, it's dy. Remember, y is the second variable, so y should be replaced with the constant, which is 2, 9, 10, and the x and z column wouldn't change. Then afterward, we have to calculate this determinant, do all the calculations, simplification, and then the final answer would be negative 8. The last determinant would be dz. So z is the third variable, x and y doesn't change, but the third column would be replaced by the constant, and then it changes this 3 by 3 determinant will be breaking down into 3 2 by 2 determinants, and the final answer would be 12. Okay, next and last step would be calculating the value of x, y, and z. So the x would be 1, the y would be negative 2, and the z would be plus 3. So don't forget to always check your answer. So you have the values, go back, substitute the value, and make sure your answers are correct. I hope you enjoyed this video. The practice time videos are videos that I only do and solve practice questions for you, because as I just mentioned, practice makes perfect. Don't forget to subscribe to my channel. See you next time.